right. Hello, math kiddos. Unfortunately, I had to be out today, but I will be back tomorrow. So, happy Tuesday. Today is April 11th. And as you notice, today's plan, we're going to get started with our do now, and then we're going to look at subtracting equations. So very similar to yesterday, adding equations. Today we'll look at equations that have subtraction. So reminder of your homework is to make sure you are working on completing your ALEKS topics. If there is time at the end of the period today, then you may start your ALEKS topics or work on them. But other than that, we are focusing on the do now and on the lesson video for solving equations subtraction. Okay, so open up your notebook to page 80, and your do now for today looks like this, where the missing number is 3. You're being asked to evaluate the expression when n equals 3. So substitute 3, take a few minutes, and work it out. Okay, so that should have been enough time to work on the do now. Let's go ahead and go over it. Okay. All right, so on page 80 for Tuesday the 11th, we said evaluate when n equals, what's the missing number? 3, that is correct. Go ahead and grab my markers. All right, so n equals 3. So basically that means anywhere you see 3, I substitute that in. Not 53, but 5, times 3, and 3 to the second power. All right, so n is 3. There it is. All right, now it becomes just like Monday, where I have to simplify this numerical expression. So it is separated by plus and minuses. So here's a plus, here's a minus. That means I have 3 terms. Okay, so I end up with 5 times 3, which is 15, plus 28 divided by 7, which is 4, minus 3 to the second power. Yep, that is 3 times 3, which is 9. All right, now in order from left to right, so I have 19 minus 9, which is 10. Check your work, fix anything that needs to be fixed. Okay. And then let's go ahead and move on. So yesterday we talked about an expression. So these are expressions and how it is different than an equation, right? So equations are different because they have an equal sign. So yesterday we discussed the difference between those two. And then yesterday we also took a look at equations that had adding. They were all adding type equations. So the inverse for all these problems we did yesterday was subtraction. Subtraction to isolate the variable. Okay? All right. So today, if I can get a volunteer or if our guest teacher can go ahead and pass out the foldable notes for today so we can get started. You may pause the video if needed, but once everyone has today's notes, then we can go ahead and begin. Okay. I think we are just about ready. All right, so equations, what does it mean? So when solving equations, remember we discussed yesterday that our goal is to what? Is to, yes, isolate the variable. And so remember, isolate means to get the variable by itself. Right? So you get the variable by itself on one side of the equal sign to find out what it is equal to or what it is worth. And then remember an equation. An equation has an answer for the variable. So that's why it looks like this, where you have the variable is equal to an exact answer. So with the equations, you end up with an answer looking like this. Okay. So we said isolate is an important word. It means the variable is by itself. All right, so how do we solve for equations? How do we isolate the variable? Well, when solving equations, we use, what's that math term again? Yes, inverse operations. Good. And basically, the reason why we use inverse operations is because they undo each other. So inverse operations is a math key term, which means they undo each other. All right. So the inverse operation for subtraction, because all of these are going to be subtraction problems. So the inverse operation for subtraction is to undo. It is addition. Okay, so let's prove it. Let's do proof of that inverse operation. All right, give me a number that I can add to 10. 5, okay, I heard 5. So if I add 5, I get 15. And then, oh, I don't think these were fixed. Let me fix these. Oh, that's why I fixed this. Sorry, guys. I fixed this when I wasn't supposed to be fixed, but yours is fine. Okay, so we have a subtraction problem. You gave me a number. I heard 5. So if I subtract 5 from 10, I end up with 5. Well, if I do the inverse of subtraction, so if I do the inverse of subtraction, which is addition, and I add 5, I end up back with its original number. So I undid it. Okay, so I have $10. I gave $5 to my friend, but then my friend didn't need no more, gave me that $5 back. I now have $10 again, right? So the inverse of subtraction will be addition, and the reason we need to do that is so that it can undo each other, so that way we can isolate the variable to get our answer for the equation. Okay, so let's go ahead and take a look. All right, so today you don't have the algebra tiles, but we will draw them, and I am going to show you. So remember, like yesterday, there was a few problems that we were able to do in our head mentally, right? These are going to be very similar. Some of these we're going to be able to mentally do in our head to get the answer, but we still need to show the work to prove the answer. So the first one is x minus 5 equals 2. So what number, take away 5, is going to give me 2? Some of you know what that is? Yeah, it's 7, right? Why? Because 7 minus 5 is 2. Okay, so let's show that first by using the algebra tiles. Okay, so 7 minus 5, so these are all subtraction problems. And then on the other side of the equals 2. All right, so my answer is 7. I need to figure out a way how to isolate the variable to get the answer 7. So yesterday we talked about whatever side the variable's on, I need to look at that number. And I need to create a 0 pair to remove it to isolate the variable. So if this says minus 5, I will have to add 5. So that ends up with 0 pairs, isolating the variable. But if I add 5 on that side of the equal sign, I also have to add 5 on this side of the equal sign. Just like that. Right? This gets 0 paired. Here we don't have 0 pairs, so I end up with x equals 7. Okay, so let's go ahead and show that work. So I have x shaded in if it's positive. Keep it empty if it is negative. I have 2 different colors I can use, but when we don't, shaded means positive, not shaded means negative. And then 2. All right, so let's try to remember, what do we do here to isolate the variable? Okay, so that is minus 5. So to create 0 pairs, I'm going to add 5. That creates 0 pairs to isolate the variable. Whatever I do to one side, I must do to the other. So I have to add 5. Okay. Same thing here. That's minus 5. So what did I do? I added 5 to both sides to isolate the variable. Now it's all by itself. All by itself. And then I do the math. 2 plus 5 more gave me 7. 2 plus 5 is 7. So we're using both tiles and algebraically to show and prove that when I do the math, I end up with x equals 7. Why? Because 7 take away 5 is 2. Okay, let's take a look at the next one. All right, so I have 4 positives. And that is equal to x minus 6. Okay, this time x is on the right side. So to get x by itself, to isolate x, I'm going to do the inverse of subtracting 6, and I'm going to add 6 positives. So that way these cancel each other out. So here, add 6 positives. And I'm going to do that to both sides of the equal sign. Just like that. These are 0 pairs. So the x got isolated. These are 0 pairs. So the x got isolated. And now I just do the math. 4 plus 6 is 10. Just like that. And it makes sense because if I plug it in and I have 10, 10 take away 6. I have 10, take away 6, I end up with 4, right? All right, let's take a look at this next one. Now I have x minus 1. So I have x minus 1 equals. Okay, so my Chromebook, my laptop died. So here it is. We were on this problem right here. So I have x minus 1 equals negative 6. Okay, so we need to isolate the variable. So the variable's on the left-hand side, and there's a negative 1. So to create 0 pairs, I need to add a positive 1. That creates my 0 pairs. So whatever I do to that side, I have to add a positive. Let me shade it in. A positive 1 on this side as well. So here, algebraically, add positive 1, add a positive 1. This was my 0 pairs. Just like above, my x got isolated. Here, my x is isolated. All right, now, using the tiles, I am able to see that I have a 0 pair. So I ended up with, 1, 2, 3, 4, 5, 6. So once I get rid of my 0 pair, I end up with 5 negatives. Here, I have to go back and remember the rule for integers. So these are different signs. So different signs subtract and keep the sign of the one with more. There are more negatives, so I end up with -5, just like above, -5. Okay? All right. So the rest of them, we're going to do them without our algebra tiles. Okay? We're just going to show the math algebraically. Okay? So the first one is x minus 15. So what number, take away 15, is 20? Maybe you think of that in your head mentally. What do you guys think? That's 35, right? 35 take away 15 will give me my 20. But let's show that algebraically. So cover that up. The inverse of subtracting 15 is adding 15. That creates my 0 pairs, and my variable is isolated. Let's see. Okay. And then whatever I do to one side, I also have to add 15 to the other side. Do the math. I end up with 35. Okay. Let's do one that's negative. Let's do like this one below. So the x is on the left side. So the inverse of subtracting 4 is adding 4. So I'm going to add 4 to both sides. My 0 pairs. So my x got isolated. All right. Pay attention very carefully here because I have negatives and I have positives. Okay. If I want to draw the tiles, I could draw the tiles, or I can remember the pattern. Different signs. So I'm going to subtract. So I got to borrow and regroup. 11, 10, 9, 8, 7. And that's 1. So I had to subtract and I had to keep the sign of the one with more. There's more negatives, so I end up with more negatives. So it is -17. Okay. So I'm going to give you about 10 minutes. You are going to show the steps. You're going to show the work exactly like we've been doing it for these 6 problems. Then I'm going to share the answers with you in the work to make sure that you actually did them correct. Okay? So now take the next 10 minutes or so to complete the rest. Once you are done, so if you are done before the 10 minutes, I am going to share with you the answers, and then I'm going to ask you any time left over to work on your ALEKS topics. Okay? But this gets done first.